right, guys, we are on page M224 and we're going to talk about factors. So we have been talking about factors quite a bit. That's pretty much what we've spent the last 2 days on, and time before that too even. So what we want to do today is be able to factor something and find the zeros when big X, box, GCF, difference of squares, and grouping don't actually work. And so this happens quite a bit when we actually look at real polynomials, and so we want to use some different methods to find out, like I said, the zeros without actually doing one of those factoring methods. So if you look at this polynomial here, I have x cubed plus 12x squared plus 41x plus 72. And you can see that it is a cubic function, right? It has got a relative maximum, a relative minimum, and it does have a zero. It's only got one of them, but it's right there. And so there's 1 0 at x equals -8. So we would then assume that x plus 8 times something is going to make this. So normally we'd move from this step to this step, right? And we'd try to group it or something, GCF. But we can't do that in this case. We know one of the factors is x plus 8. But how do we find this part? Like, what do we do? Now, factors multiply together to make a polynomial. Well, what's the opposite of multiplication? It's division, right? So we're going to use division to find out what this piece is. This factor theorem is what we've already been using. We just haven't explicitly said it. If x plus 8 is a 0, right? And x equals -8. When I plug this into my function, I should get out 0 because it's called a 0. That's factor theorem. So if you know a 0, it should plug in and equal 0. So if you see down here, when I took -8 and I plugged it in for x, I got out 0. That's why it's called a 0, right? X-intercepts have a y value of 0. They have an output of 0. So x plus 8 is a factor, okay? So we're going to be doing what's called polynomial long division. And it looks pretty scary right now, but it's actually pretty similar to integer long division. So if I took 3,660 and I divided it by 12, I'd ask myself, okay, how many times can 12 go into 3? Oh, it can't, right? So how many times can 12 go into 36? That's 3 times. I do 3 times 12, and I subtract. I bring down what I have left, and I ask, well, how many times can 12 go into 6? Well, 0 times, right? Bring down your next. How many times can 12 go into 60? 5 times. 12 times 5 is 60. Subtract. I have a remainder of 0. When we do polynomial long division, it's going to be the same process. We're just using x's. So I'm going to illustrate that over here. So I'm going to take x cubed plus 12x squared plus 41x plus 72. And remember, we said that x plus 8 was already a factor. So I'm going to divide it by x plus 8. So I'm going to really focus on x. So I'm going to ask myself, how many times can x go into x cubed? And another way to think about that would be, well, what times x would make x cubed? X squared, right? So x squared. Okay, I'm going to keep everything really organized, so I'm going to put x squared up here. I'm going to distribute. I'm going to do x times x squared is x cubed. X squared times 8 is 8x squared. And I'm going to subtract. That's very important. I'm subtracting. X cubed minus x cubed goes away. That's what we want. 12x squared minus 8x squared is 4x squared. I'm going to bring down my next term. And I'm going to ask myself, well, what times x makes 4x squared? 4x. So I'm going to distribute. 4x times x is 4x squared. 4x times 8 is 32x. I'm subtracting 4x squared minus 4x squared goes away. 41x minus 32x is going to give me, let's see, 9x. I gotta bring down my next term. So then I'm gonna ask myself, well, what times x would make 9x? 9 times x is 9x. 9 times 8 is 72. When I subtract these, everything's going to cancel, and I have a remainder of 0. That's what I want, okay? I already said x plus 8 was going to be a 0, so I should get a remainder of 0. But what this tells me is if I took x plus 8 and I multiplied it by x squared plus 4x plus 9, I would get x cubed plus 12x squared plus 41x plus 72. Now, you're probably going to want to pause here and watch that again. You can pause as many times as you want. Pause and watch it again. Think about the questions that you have. Write them down so that we can talk about them tomorrow. I'm scrolling and scrolling and scrolling, and I'm going to end up on page M230. And I'm going to try another one, okay? So I have x cubed plus 2x squared minus 5x plus 16, and I'm going to divide it by x minus 4. Again, we're really going to focus on x. So I'm going to ask myself, well, what times x makes x cubed? X squared, right? So x squared times x makes x cubed. X squared times negative 4 makes negative 4x squared. Now we are subtracting, okay? So you need to be careful. This is going to cancel, but 2 minus a negative 4 is going to make a positive 6x squared. Use your calculator if you need to. Now, what times x would make 6x squared? Distribute. So 6x squared minus 24x. Again, we are subtracting. You need to be careful. Cancels. Negative 5 minus a negative 24. So minus minus really makes plus, right? So this is going to be 19x. And I'm going to ask myself what times x makes 19x. Distribute. So 19x minus, I don't know what 19 times 4 is. It's 76. I'm subtracting. I am subtracting. Be careful. That's really going to cancel and have 16 plus 76, which is 92. That's not good. It's not good. That's telling me that's not a factor because the remainder wasn't 0. But we can still write our final answer. So we're multiplying all this stuff, but we have a remainder. And the way you write remainders is like that. So that was my remainder and what I divided by. Again, watch this again. Pause it. Doesn't matter. Take as much time as you need. And I'm going to do one more. Now, something important is you always want to stay orderly. So if you're missing something, like this is missing an x cubed, I'm going to put 0x cubed as a placeholder, okay? I can't just like skip stuff. I need to stay organized. So again, I'm focusing here. What times 2x would make 4x to the 4th? Definitely need an x cubed, right? And a 2. So 2x cubed times 2x is going to make 4x to the 4th minus 6x cubed. I am subtracting. Subtracting a negative makes it a positive. Cancel 0 plus. Bring it down. What times 2x would make 6x cubed? Again, we're staying very orderly. Notice how we keep going x cubed, x squared, x constant. So definitely need an x squared, but I also need a 3. Because 3x squared times 2x is 6x cubed. And negative 3 times 3x squared is negative 9x squared. I am subtracting. Be careful. 5x squared minus a negative 9x squared is a 14x squared. Now, something to keep in mind. If these don't cancel every time, you screwed up and you need to go back. Now, what times 2x would make 14x squared? Definitely need an x, but I also need a 7. So 7x times 2x is 14x squared minus 21x. I am subtracting. Negative 7 minus a negative 21x, okay? Cancel. This is going to become a positive 21, so that's 14x. Again, what times 2x would make 14x? I'm going to always end with a constant. It is purely coincidental that those are both 7s. There is no trick to that, okay? 7 times 2x is 14x. 7 times negative 3 is negative 21. I am subtracting, so that's 9 plus 21, which is going to make 30. That's definitely not a factor. It's okay, though. You can still write the final answer. Again, please watch this video, write down your questions so that we can discuss them tomorrow. I expect everyone to have at least one question. This is kind of a difficult topic. It is also something you really need to take your time on. Take your time on it. Now, I have posted the homework that includes this. There are some using this method and some using the method we're going to do tomorrow. If you want to start trying a few of these so that tomorrow we have good questions, that would be great.